The Declaration of Independence, signed 237 years ago, stands as a daily reminder of our liberty and freedoms that we as Americans enjoy every day. All around the nation we celebrate this day, known as Independence Day, with friends, family, and of course, the most exciting part, fireworks. Our founding fathers believed that Independence Day should be celebrated with bonfires and illuminations from one end of the continent to the other, from this day forward, so on and so forth. So today, what we're going to do is we're going to spend a little bit of time, we're going to talk about the anatomy of a firework, we're going to talk about the physics, and we're also going to talk about the chemistry that's involved with it as well. How many of you have ever sat down and watched the fireworks and wondered how they actually happen? A few of you? Wow. I just used to sit there and look at the beautiful color and say, wow, that's amazing. You know, we take a lot of things for granted here, but just to start off, first off, the anatomy of a firework, okay? So, first things first is a launch tube, okay? Now the launch tube, sometimes referred to as a mortar, are the tubes that are typically 3 times the size of the actual firework, and that's what actually keeps it going straight up in the air. You know, it protects the rest of us on the beach so we don't get hit with things as we fly. So lift charge. What the lift charge is this very small, compact amount of black powder. Okay, and what that does, that's actually the charge that shoots the firework up into the air. Now fireworks have evolved over the years, but what it's actually gone to is now they can shoot up as far as 1,000 feet up into the air. The main thing is though, this lift charge, if it's not packed strongly, what can happen is the charge that actually shoots up the firework will disperse and then the firework can blow up right there. It can be a mischarge. So the main fuse is the initial point of contact between the ignition and the rest of the firework itself. So what it actually does is it's a secondary, when it lights a secondary fuse that will in fact light off the lift charge, and then it also lights off the fuse that goes into the center of the firework there. The black powder, the reason it's used in fireworks, it's a low explosive. And that black powder is actually used to light off the next part we're going to talk about here that actually is the fun part. It actually shoots off all the colors when it shoots up. So the next we come to is the stars. The stars, they're small combustible pellets that these were actually handmade by the pyrotechnician, the person making the fireworks. They go and actually hand make each and every individual piece of that. You know, so every firework, you know, that we take for granted, each one of those were handmade by someone. Each color and all the different designs. We're going to talk a little bit more about this in a few minutes, but they can be different colors, sizes, and shapes, and that determines what the actual firework looks like. Okay? The time delay fuse, this is really one of the most important parts here. What the time delay fuse does, it goes down, it's how you get different levels of firework. When one firework shoots up, you get a couple different colors on the way up. That's thanks to the time delay fuse. And then last of all, you have the brakes. What the brakes are, they're individual compartments that hold all the different stars and the different colors so that you can actually get the different, the different displays. Okay. I'm no physics teacher, but here we go. The physics and mechanics of aerial fireworks. So what these are right here, guys, these are actually spherical fireworks. Okay, so what it is, it kind of looks like, I don't know if you all ever played any video games, but like the little Mario Brothers, right, the little bomb? That's what these are. They look like, almost like a beach ball. So what you have is you have the fuse, okay? Then you have the stars, which are these little specks right here that you have. You have the charge detonation, then you have the gunpowder. So, the fuse, okay, the fuse and the charge is actually what determines the altitude that the firework is going to go off on. So the smaller fuse may be 500 feet. The firework will go off at 500 feet, where the longer fuse and the charge will mean something at a higher altitude, so maybe 1,000 feet or whatever it may be. Okay. Now what the stars are, as we talked about, they're the small compact pellets. Now you have, and for instance, this one you have all sorts of different colors, different sizes. Again, this is going to give you all those different, the beautiful colors that we take for granted. Okay. Now these right here, these pellets are actually, they're two different colors. So that's when you see that one go up and it bursts and it's the blue and then it bursts again into the purple, how it does two different colors. That's because someone sat down and hand packed those and then packed another, gunpowder, powder around it. And then this area all around it, around the fuse and around the detonator is gunpowder, okay? Now what you have right here, different shapes. These ones, for instance, are cylindrical. These are gonna give you those really nice streamers of color that you see, rather than these ones are more like a circle color when it goes off. So you see some really nice streamers, and then you have different patterns. So when I say that these are hand done, I mean someone is sitting down and they're making these different designs that they actually make in the firework can create, a heart in the sky or a smiley face or, whatever it may be. That's what actually creates all of the different designs that you see in the sky. So someone actually hand does that. So it can be a very intricate work. Very intricate. Now the chemistry of color. Again, we take a lot of things for granted in life, but what we have here is the stars, the actual stars I was talking about, the small pellets that actually give your color, are laced with chemicals and elements that react to produce a variety of colors. When heated, the atoms of each element in the mix absorb the energy, causing its electrons to rearrange their lowest energy state to a higher excited state. Makes a lot of sense, right? A lot of jargon. As the electrons plummet back to their lower energy state, the excess energy emits it as light. The black powder is mixed with different components to make different colors. So as you can see here, aluminum and magnesium. These are the two elements needed to make white light. You have lithium and strontium. Those are the two elements that make red. You have sodium. The element sodium makes yellow. You have copper, which is blue, barium, which is green, and then you have carbon, which is orange. The stars are laced with these elements and then mixed with other chemicals and oils to make an explosive gas when heated. So in conclusion, this firework, these beautiful displays that we see, we take for granted every 4th of July or whenever, we go out back to shoot them off. A lot of intricate work goes into actually making these, these beautiful displays. And what we went over is we went over the physics and the mechanics. We went over the chemistry of color, and then we also went over the anatomy of a firework. So next time you're sitting there on your 4th of July on your roof or with loved ones or sitting out by the pool and watching those fireworks, think to yourself, I wonder how much time someone actually put into this display so that we can enjoy it. Thank you.